Okay, hello. This is what class 11 of Intro to Physics. Um, Thank you for showing up today. I know it's a Sunday, so it's busy, but uh I'm gonna be tutoring today. Lucas is not able to join, and we have Justin as a TA. So yeah, we already posted homework for today, just so you guys can get like started on it. Sorry that we didn't. Sorry, our recording, we posted the recording pretty late. I took a while to upload and then I forgot to post after it fully uploaded. So, um, but if you guys have any questions, I marked Jethan as a TA so you can private message him about anything. But today we're going to be learning about uniform circular motion. Do you guys know anything about uniform circular motion or not really? I know we did a bit of it with I know you guys did a bit with Lucas about like the centripetal acceleration, but I know you guys didn't do much. So um first of all, let's I thought I had a picture. But first of all, let's start off with just a thought question. Okay, this is to almost you can think of it as a thought experiment, right? If oh sorry. Okay. If there's a car and it's going around a circle, right? Let's say this is a track and this car is going around, this is the car, and it's going around this circle. Do you think its speed is changing while it's going around the circle? Just the speed. So if it's like going 20 miles per hour here and it's just driving without pressing he's just pressing the pedal at the constant 20 miles per hour. Do you think the speed is changing? There's no trick question to this. It's just a simple question to answer. No, no, no. Yes, you guys would be correct, right? The speed is gonna be 20 miles per hour, whether it's here or whether the car is here or whether the car is here, right? That's the speed. Remember, I don't know if you guys were here, but we talked about um speed, like velocity, being broken up into two things because it's a vector. A vector means it has magnitude and it has a direction, right? So what that means is that velocity has one magnitude, which will measure its speed, right? But it also has another, which measures its direction that it goes in. There's two components to velocity. So on this track, do you think the direction of the car is changing constantly? My car's not perfect, okay? Or my circle's not perfect. Yes. The car is changing direction constantly. So that means its velocity is technically changing. It's just it's the speed will be the same. It'll be going 20 miles per hour, but the direction it's going is changing. So that means that this velocity is changing. And what do you know about velocity changing? If velocity is changing, what does that mean? Velocity changing means that there's acceleration, correct? Remember how acceleration's the change in velocity? Acceleration equals I'm just gonna do the triangle V, right? Change in velocity, correct? So even though it's going the same speed, since the direction is changing, that means the acceleration is also changing, right? I think there's a picture on the next slide. Do I not? Oh, it's okay. It's on the next slide. But um, so this means that so now we can get into uniform circular motion, right? Because we the velocity is changing because let me clear. Oh yeah, this slide does a good job of explaining it as well. So velocity has two components to it: speed and direction, correct? There's one component of the velocity that stays the same, right? 20 miles per hour, right? This stays the same wherever this car is on the track. But this car is constantly going a different direction every time it's on this track, right? And since it's going a different direction, the change in direction also means there's a change in velocity, right? Due to direction. Does that make sense on why wait, if you want to do something? Yeah, yeah, you're constant. That's why I'm saying you're constantly changing direction whenever you're in a circle. That's a good comment. Does that make sense why the velocity is changing, Sinchana? Because if the direction is constantly changing and direction's a component of velocity, that means velocity is also constantly changing. Does that make sense? Yeah. Mm-hmm. Sanchana, if you still have, oh, so in any case of direction or speed is constantly changing me. Yes, 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 yes. And since, yeah, it could be direction or speed or direction and speed or both combined. Yeah. But that also, since we know that velocity changes, that means there's acceleration on it, right? And this is what the underlying like lesson of uniform circular motion is, right? We're trying to we're trying to learn about this acceleration that's acted upon this object, right? Because we know that there's a change in direction, but we want to figure out what the acceleration, constant acceleration is, right? So, Jethin put something in chat. You guys can read it, but I'm gonna move on. So like, ooh, there's also yeah, I linked the gizmos. We'll do the gizmos as well. But if you like, this is the picture that I was trying to see. Like, we'll get into all this stuff later, but there's going to be some. There's gonna be. Actually, I'll just use this, right? Don't worry about any of this here right now. But you remember this car that we were using? Let me hide names for annotation. Okay. You know this car that's here, right? Remember we talked about this velocity? Since this velocity is going this way, there's going to be a constant centripetal acceleration pulling the car inwards to constantly change the direction, right? In order to keep this car going in a circle, there's a constant acceleration inwards to keep on changing the to keep on changing the direction. And you can almost think of it as like as different things in different scenarios, right? If you're looking at if you're looking at a ball tied to a string, a tennis ball tied to a string, that constant or the centripetal acceleration comes from this string, right? Just so this ball can go in a circle. For this for this, it's like friction and like just around this point. Does that make sense to you guys of how like this there's that like you can think of the for or the acceleration inwards as the reason why this car keeps on changing direction. I think that's the best way to say it, actually, right? Let's see if my gizmos work. It is curving. Yeah, 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 yeah. Let's see if my gizmos works. Ooh, it does. Okay. Can you guys see my screen? Okay. I only have 5 minutes to do this, but it kicks me out after 5 minutes. But if you look here, right? We can play this. How do you, oh, I can just make it slower by doing this, right? If you look at this, you can see that the less velocity, you see how the arrow for this arrow inwards gets larger or smaller. We'll talk about why later, but just keep that in mind. And then as you can tell, mass doesn't make a difference at all in this. And radius makes it also go faster and slower, right? We'll talk about why all of this later, but I just wanted to show you guys this cool gizmos. Um, I don't think you guys need to see the other. Yeah, the description is the best. But yeah, that's just the cool gizmos I had. Okay. Increasing the radius, uh, increasing the radius lowers the speed, yeah. And then decreasing the radius increases the speed. And you can kind of like think about it logically, right? If you go around a circle and the radius is smaller, that means you have to change your direction a lot quicker than if you have a larger circle and you have to go over a longer period, right? Then the curves are kind of smoother almost, so then you have more time to change direction versus if you're going in smaller, so you have to change directions way quicker, correct? That's why acceleration with a smaller radius is and like these are the most important terms we'll be working with today. You'll look at like you're talking about the radius, the velocity of the object, centripetal acceleration. Remember, centripetal acceleration is did I? So basically the centripetal acceleration is just the force um that acts inwards towards the circle. And you'll notice that on a car or any object really, that the velocity always creates a 90-degree angle with the centripetal acceleration. That's because like in order to like I don't know how to explain this, but if this car was going straight, it would go like this, correct? But since it's being pulled in, it's just the arrow goes towards a circle and it creates this 90-degree angle every single time. If the car was right here, then the velocity will be going this way, and then the centripetal acceleration will be going this way. Correct. And it creates this 90-degree angle. You can look at it for any point in this circle. And basically this inwards is just we label that as centripetal acceleration or A sub C, right? Because it's just acceleration inwards due to the centripetal force, right? Inwards acting on the object. And we'll talk about later what like because centripetal force is like a lot of different could be because of a lot of different things. Like it could be because of like the tension, it could be because of friction, it could be because of gravity. It's not like an actual thing. It's just like we label it centripetal force, but it's like different things that it could technically be, right? And these are like the important terms to know. We label F usually as F sub C because this is gonna be force due to the centripetal acceleration, and we know that F equals ma, right? F equals ma. This should be in your guys' head by now. So then, F sub force due to centripetal acceleration would just be F sub C times mass and acceleration due to centripetal force, right? And I should really write A as this here. Right. Does that make sense to you guys? Oh yeah. The question earlier, it doesn't change the velocity, but it changes the acceleration. And then I don't like deriving this equation would like take a lot of work with like proportionalities and everything, but you guys should remember that acceleration due to centripetal or the centripetal acceleration is just equal to v squared over r, right? And remember we talked about how like 1 over r plays the role because like if you increase r, then the denominator gets bigger, right? Increasing r um increases the denominator, and if you have a larger denominator, that means you'll have a smaller value, right? 1 over 100 is less than 1 over 1, right? So that means, like since Shana said earlier, increasing the radius usually, and you can think of it again, you can think of it pretty logically. If you have a smaller circle versus a bigger circle, you have to change your direction faster on the smaller circle versus like you can be more relaxed on the bigger circle. And if you look at velocity, velocity plays even a bigger role because velocity squared is directly related to velocity squared is directly related to, and this is what you call a propor relation. I'm just gonna say relation. I can't talk right now. But they're related to each other, right? If you look, if v squared r or v squared gets bigger, then the acceleration, centripetal acceleration will also get bigger, right? And you can play around with it again. If you go back to that gizmos, increasing the velocity greatly increases the centripetal acceleration, and saying does or and r also um changes the centripetal acceleration. That's just because, oh, and then, yeah, yeah. If you think about why velocity plays a role, it's just because if you go around the circle and you're in a car, if you're going a lot faster, then you're constantly changing direction a lot more than if you're going slower in a car, right? And that plays a role towards the center. So make sure you write this equation down in your notebook or whatever. You can write centripetal, you can write a sub c equals just v squared over r, right? And then if we tie this back to force, we remember force is equal to mass times acceleration. Remember I told you F sub c is equal to mass times centripetal acceleration. So the centripetal, and remember, we just covered this, right? Bang. So, and then like these are the examples I was talking about earlier, but if you substitute the centripetal acceleration with v squared r, or sorry, v squared over r, you just get centripetal force is equal to mass times v squared over r. Does that make sense to you guys? How we did that? Yes, I just substitute it. Are these questions that you were seeing on the Blookit? I forgot what the questions on the Blookit were looking like, but is this like what you were seeing on the Blookit as well earlier? Yes, no, maybe so. I'm not seeing much. Okay, I think so. Yes, and no. Were there other stuff also? Um, okay. Um, this makes sense to you guys though, right? What I covered so far. And then, okay, we have a thought experiment, right? You guys have probably seen this, where if you spin a bucket of water around a certain point fast enough, the water just doesn't spill out. Does anyone have an answer on why that is? I'll give you guys 2 minutes. 2 minutes to think, or think, or write, or DM me or Jetin why you think that is. Hello, Miranda. We were just working on centripetal, centripetal acceleration and uniform circular motion. Feel free to go back and look at the recording to cover what, like once I post it, obviously. Sorry, I'm not going to be able to respond to everybody. Okay, so I think a lot of you guys got like um have a different way to think about it. But basically, once you end up like you have to spin it fast enough so that this water in the bucket and this bucket act as one system almost, so that you spin it fast enough that this water just constantly changes direction with the bucket, correct? So if you don't spin it fast enough, what will end up happening is this water won't stick with the bucket because gravity is large enough to where the bucket or the where the water is just able to fall out instead of um go with the bucket. So that means like the bucket isn't changing direction fast enough for the water to stick with the bucket, correct? Um, you guys want it's a 1 minute video. I think I'll just put it on. Um, can you hear it? Tell me if you guys can't. Oh, you guys can't hear it. Uh, really, you guys can't hear the audio? That's a bummer. That's a bummer. Okay, wait. Can you guys can you hear that or no? I think I'll just put captions on then. Hmm. So basically, what he's trying to prove with that water glass is that like the water is falling with the glass, correct? Like, so if he moved the bucket of water fast enough for the bucket, they'll just go around together. So as soon as he stopped moving that bucket of water above his head, gravity immediately was strong enough, like overpowered the centripetal force, and it just dumped the bucket of water. That's basically that's the part I wanted to show. There was a bit earlier, but that was just um oh yeah, I can give you guys the link. That's the link to the YouTube video, and then I can also give you guys the link to the gizmos. Okay. This is the link to the gizmos, and then I linked the video up ahead. Okay, so we'll solve one of these questions together, actually. Or actually, I'll give you guys a few minutes to do it on your own, and then we'll solve it together. A bucket of water is filled with water and swung in a vertical circle, right? So it's swung like this. Ooh, I can't, sorry. Okay. It's swung like this, and the distance from the hand to the bucket or from the center is just 1.5. This radius is equal to 1.5. Do you guys want me to, I'll write the equations down as over R. This sub C just stands for centripetal. So centripetal acceleration, centripetal force, and then you guys know that the force of gravity is just mass times the acceleration of gravity downwards, right? You just need all this. And then just private text me or Jethan once you guys get your answers. I'll give you guys until 46. Oh yeah. Guys, I didn't solve the problem yet, so I don't know the answer. I'm gonna solve it with you guys. I'm just if you give me your answers, I won't be able to tell you guys if you're right or not. 'Cause I didn't solve it. I like this problem though because it's like very like realist. Like you'll see this in like when it's like a party trick, you know. People do it as a party trick, and then you know the reason why they can do it, and you could actually figure out how much they're accelerating to do that, or how much they need to do that. And yeah, I've only got one answer. Oh, okay. I think people are stuck finally. Does anyone want to? I'll before I give it. Does anyone want more time? Does anyone want more time? Also, you guys, feel free to like experiment with the equations because like I gave you guys the three things you need to figure out how to do this problem. So, uh, yeah, just like try to input thing. Oh, sorry. Try to just input things where like they should go, and then like, um, make sure you guys give the correct units. I am not seeing correct units. All right, go ahead and solve it. Okay, so basically. You guys know that let's list all the things we know, right? We know that there is a radius of 1.5 meters. We know that G is equal to 10 meters per actually meters per second squared through our other classes. And we know that we need to figure out v, correct? How fast we need to rotate it. Do you think you guys can do it through there? V is for the people who haven't done it yet. Does this help a bit if I label out the variables like this? Question mark, right? So at the top of the circle, the so basically we're trying to figure out just barely stays inside, correct? So we have to figure out that the force, you can even do an inequality here, right? The centripetal force has to be greater than the normal force, right? Or the force of the force of mass times gravity, right? Um, so what you can do here is you can just substitute this for mass times centripetal acceleration is greater than mass times gravity, right? Because we're just substituting F for here and we're substituting this for here. We can make one more substitution here. We can do this equals V squared over R, right? So M V squared over R is greater than mass times gravity. And the reason I have a greater than symbol is because we're trying to keep the water bucket to stay inside, right? So if we want to keep the water bucket to stay inside, it says to barely stay inside. So if you wanted to barely stay inside, you would just set these equal to technically. But if you did the inequality, you would get the same thing, but you would also get other values that could equal. But I'm gonna stick with the inequality. So should do greater than or equal to then. So we can clearly cross out m because m doesn't matter. We'll talk about y later. But and notice that it doesn't even give it doesn't give us the value of m, which means that it is not needed, right? I was debating when I created this question, I was debating whether to write a 1.5 kilogram bucket or just erase it. And I decided to erase it because we would talk about why we don't need it. So we can clearly cross these two out, and then we just get v squared over r is greater than or equal to g, correct? So then you have v squared is greater than or equal to g r. And look at that, we have both values for g and r, so we can just plug that in. 1.5 times 10 is equal to 15. And then you just get v squared is greater than or equal to 15. You square root each side to get v is greater than or equal to square root of 15. So the velocity can be 15 meters per second. I just thought you guys had I'm gonna rewrite it for to make it a lot. I'm gonna rewrite it. Yeah, I'm gonna rewrite it. This is just like my initial thought process, and I'll rewrite it again so it can stick in your head, stick in your guys' head. But like I think most of you guys had like either no units or you guys had the wrong units. I saw a lot of you guys had miles per hour or you guys just wrote the answer. And over here, it's actually meters per second because look how we're using meters per second squared here and meters here. So, yeah, let me go through this clearer now. Okay, so I'm gonna keep the equations up here. V squared over R F C is equal to M A sub C and F is equal to M A. Correct. These are the three equations we need. And then we can identify our variables. The radius is equal to 1.5 m and the gravitational acceleration is equal to 10 meters per second squared. Okay? Now we can go to step one, right? Step one is identifying what um ooh, right, you're right, sorry. MG. Good catch. Step one is identifying the fact that the centripetal force needs to equal, or it needs to be equal to or greater than the force of the gravity pulling the water downwards, correct? So we're gonna write FC needs to be greater than or equal to, uh, sorry, got carried away there. F. The second step is now just substitution, right? Substitution for the centripetal force, which is just mass times acceleration. Centripetal acceleration is greater than or equal to mass times gravity, right? Then the third step is even more substitution for the centripetal acceleration, right? We have to bring this in, so we just get mass times velocity squared over r is greater than or equal to mass times gravity, right? Step four then is then starting to solve for v because we're trying to find v, correct? So we just cancel out the masses, so you just get v squared over r is greater than or equal to mg, right? Oh, sorry, not mg. Oopsies. Does this so far make sense to you guys? Or kind of? I think it all stems from the fact that you need to know that we are trying to find the that the centripetal force means that that translates to like the water staying in the bucket, right? So think of centripetal force in that case as that, right? Centripetal force is equal to water staying in the bucket, and then the force, the mass times gravity force is the force that will bring the water out of the bucket, right? And in this problem, we want the water to stay in the bucket. And remember, we just talked about how the water staying in the bucket means that translates to the centripetal force. So that means this is just equal to that. And then this has to be greater than the force of wanting that water to come outside the bucket, right? Yeah, a lot of physics is substitution once you like figure out the equations, right? So then step five is getting v by itself. So you just get v squared equals, or sorry, is greater than or equal to g r. And then you just get sixth step is square rooting each side. So a lot of physicists will use all variables, and then on the last step, since they have this, and now they can just substitute the two values they have. So now you just get v is greater than or equal to the square root of 15. Because 1.5 times 10, gr equals 1.5 times 10, which I just substituted in there. And make sure you keep track of your units in this problem. Sorry. Jetin, can you fill in Jagat and Kritan in chat, like how you did with Miranda, just because they joined late.
Okay,
Well,
mate.
and then if you have any questions, just ask Jetin. He'll try to get to you as fast as possible. But does this make sense how I got from step one to step seven? And then you have to keep track of the units at all times, right? Radius has units of meters, and the acceleration has meters per second squared, right? So meters times meters per second squared is just equal to meters squared per second squared. And when you take the square root of that, it's just meters over second, right? So you can clearly see how like it beautifully canceled out from this to this to this, right? So then you just get the velocity. You have to be spinning it at for in order for the water to stay in the bucket, it has to be around four, around 3.8 meters per second or greater than to stay in the bucket. Now, if you just changed up like this value to like three, then you don't even need to do that much work. You just substitute three and you can skip all these steps and just go straight to step six, right? But if you inputted the radius earlier, then you would have to go back all the way over there, right? But since you already have a really nice equation, you can just input the radius here, and what do you get? 30, what, around 5 point something, right? Does anyone have questions on this before I move on? No. Does this make sense to the people who were kind of stumped at the beginning or at the beginning of this problem when they saw this problem? Yes, yes, yes. Pretty much. Okay. Um, I uh, I can't stress the fact that like just step one is probably the hardest part about this whole process, right? Even when I'm doing problems, it's always starting it that's the hardest part, right? Figuring out what the first step is. And over here, it's realizing that the centripetal force is what's keeping the water in the bucket, and the force of gravity is what's trying to take it out of the bucket. And again, this problem is saying that it's trying to find the minimum value of the velocity that can keep this water inside the bucket. So that means this water inside the bucket has to be equal to the force that gravity is trying to output on the bucket of water. So you just try to set them equal to each other and then like figure it out from there, right? And if that doesn't work, then you substitute other stuff and try to it's a lot of physics is just messing around with numbers and you'll get the right answer eventually. If you met there's no problem that you'll be stumped on if you mess around enough, you won't get. I don't know if that okay. I'm losing my mind. All right. Are we good? Can I clear my drawing, or does anyone want to take a picture of this or do anything with it? This is called, okay, so this is called the dimensional analysis, working with units. This is when you're working with units, this is called dimensional analysis. A lot of people use dimensional analysis if they're just trying to find a starting point to like figure out how a problem will work and what the end unit will look like, right? Your all drawings. And then if you weren't able to get a picture of that, go back when I post the recording, you can look at the recording. It'll have all the okay, so back to this question, right? If you noticed the mass of the bucket did not matter, right? That's because even though gravity ends up pulling it down more, the centripetal force also increases in that case, right? Remember we had this oh sorry. I'll just substitute this way for right now. If the mass of gravity increases, if mass of gravity increases, this increases in proportion to this. So they just both cancel out because both of them also increase, right? The more massive the object is, the bigger the centripetal force will also be, right? The acceleration of the object won't change because of the mass, but the force will. So in this case, they just cancel out and then it's not needed. These are some really good examples. Yeah. I don't have much to say about it. We worked out with it enough. Go ahead and do these questions for like 2 minutes. Get as many as you can in 2 minutes, and then we'll move on. Wait, I don't think we covered the first one, but I think you guys could take a good guess at what it means. If you're stumped on one of the questions, just move on. We don't want to waste too much time. Get through as many questions as possible. Ooh, Sinchana, DM, with the direct message. I know you didn't mean to, but make sure it's just to me or Jethan. Sorry, I'm on mute. Okay. I think that's enough time. But I think we're getting a lot of good answers. Good participation. I really like to see the participation in this class. I think this class out of all the other classes we host has one of the better participations. Um, like I know Python has decent, but I'm pretty sure I really like the participation in this class. You guys are good students. Okay, let's go on. So uniform just means like whenever we take a circle and something object, we're assuming that this thing is going at a constant velocity, right? If its velocity is change, ooh, I really butchered that up. Oh my God. Um, if the velocity is changing, then it's you're gonna have to worry about then this v squared over r becomes invalid because the v is not constant, right? Then you would have to figure out like the average or whatever, and like it becomes a lot. It just becomes invalid. Centripetal acceleration always points inward because it's trying to keep this circle shape, and if it goes outwards, then it would just fly away, right? What keeps a satellite in circular orbit around Earth? That's just gravity. And in that case, you can view gravity as a centripetal acceleration. That's what I mean. This case, gravity is the centripetal. I'm not gonna write that. But gravity is the centripetal acceleration. If an object moves in a circle at a constant speed, is it accelerating? Yes, it is accelerating because the direction is changing. We talked about this at the beginning of the class. Oh yeah, if you guys weren't here for the beginning of the class, this is a good review for you guys. I know Jetin texted you guys as well, but it's a good review. Since velocity has two components, right? Direction and magnitude. This, or sorry, speed and direction. Um, even if the speed change stays the same, since the direction is changing, that means velocity itself is changing, and change in velocity just means that there's acceleration, right? Um, the formula for centripetal force is just F c is equal to m a sub c, and instead of a sub c, you're gonna put v squared over r. Good. We got a lot of participation. Yeah. That's good. That's good. Sorry if you guys didn't get to answer all of them, but we don't have too much time. I think this is one of my more favorite units, uniform circular motion. Um, no, not book it time yet. 20 minutes of book it's too much. Figure out these questions. Yeah. I'll give you guys 5 minutes to do these questions. 5 minutes is more than enough, I think. Sorry, I haven't installed it yet. Let me do this. Hmm. Guys, units, please. Units. Units. Correct units, please. Correct units. And also, please try to DM. If you guys could you guys answer why it would increase for the or maybe yeah. Could you defend your answer on the second one? I didn't mean to give the answer, but if you didn't hear me, Oh, no, did I skip the slide? Sorry. Ooh, 2 more minutes. Okay. Vamos. Let's go. First question, I think it's pretty explanatory. A sub c is just equal to v squared over r. V is just equal to 4, so you just get 16 over what is r, 2, right? Radius is 2. Make sure you guys look at the wording, right? If I said diameter, do you guys know the difference between diameter and radius? Diameter is if you take a circle, the whole thing through the center is the diameter, but half of the diameter is the radius, right? Radius, both that make diameter, right? So if this was radius, this would just be, if it's a diameter and it said the diameter is 2 meters, you would do the radius is equal to 1. In a lot of physics problems, this actually does happen and it does trip a lot of people up because they assume that the radius is 2 instead of 1. So if this is 1, then the answer would be 16 meters per second squared. I did not see a lot of square. I saw meters per second, but I didn't see meters per second squared. And I accidentally um gave that to you guys, but either you guys had the wrong unit. Um, a different unit system, or you guys just had meters per second instead of meters per second squared. And remember, meters per second is velocity. We're finding acceleration, so it's going to be meters per second squared. So make sure you do that. I don't want you guys to stop focusing on that. So it's just 16 over 2 is equal to 8 meters per second squared. So the meter cancels out here, so it's just 8 meters per second squared. Next question. Imagine you is sorry, that's on me. Imagine you are spinning a toy rubber duck attached to a 1 meter string in a circle above your head. If you spin the duck faster and faster, what happens to the pull or the tension you feel on the string in your hand? Does it get stronger, weaker, or stay the same? It would get stronger, and a lot of you guys, I think everyone who um DM'd me got that right because you can tell that in this case the tension is just going to be the tension is just going to be equal to the force of the centripetal acceleration, right? And we know that so if FC is equal to tension, we can just substitute FC with tension so that you just get tension is equal to M A sub c, and we know that A sub c is equal to v squared over r. And if you increase this r, if you increase the v, if you increase the v, then you get then this whole thing gets increased, right? So then mv squared over r. If you increase this, then the whole thing and then the tension just increases as well, right? A really good way to think about this is since you just have v squared on the top. That means v squared is directly proportional to tension, which means that if you increase the velocity, then you just increase the tension. I made it like this is how like physicists would view it, but like you guys also thought about it very logically and got the right answer. Ooh, okay. Let's do book it. Let's not do one. We were supposed to cover 1D and 2D motion today, but I'll spare you guys the misery. Okay, we'll do the same book it. Let's see how you guys do. Um, let's stop recording.